in the car class. So you'll notice this class is kind of basic. We only have one instance variable. Let's add some more. Every car has a price. Well, what other things do cars have? They also have, and make sure it's private, they have a make, and make sure it's private, they have a model. So now you can have things like a $45,000 Subaru Ascent. The make is Subaru. The model is an Ascent. So now we have strings for those. So we're going to have some words associated with each car. Okay. Well, now in our default constructor, we had given it a default price because scrap metal. But so now we can make the make be, we could have it be unknown. Rather than the default constructor just giving us like a null string, we could say the make and model are unknown. So now we have some strings in place of make and model, but we also know that it's not quite filled in, so it's kind of lacking a bit. Okay, so again, we should test it as we go. So I'll even comment this business out. Let's just see how the default constructor went now that there are 3 instance variables for my car, of type car, that object. Oh boy. What happened here? Well, we better test it, right? We need our toString, otherwise, if you don't actually see anything, nothing's quite going to happen here. I wonder why it's doing that. That's like super annoying. Weird indentations here. All right, if I shift tab back a little bit, it won't be so weird to me here. I don't know why it's doing that. Okay, so now we're going to print out. Now we're going to print out using our toString, and we're going to see what exactly is going on here. Did our default constructor work out nicely with the unknowns? This car has a $500 value, but I don't know about its make and model. Oh, that's right. Well, I have only created the default constructor now with the unknown make and model. I now have to update my toString. So car, it has a make, and we need a space. It has a model, and then maybe we'll go to a new line, and we'll say it's value. Oh, actually, I don't even know if, I don't even know if I really want to say car at the beginning. I would just be like, Toyota make space model Camry with a value. And maybe I want the new line, maybe I don't. I don't know. Let's just test it. We'll see how it looks. If things are bad, we're just going to shape them. That's what coding is. It's like shaping clay on a pottery wheel. All right, so now it's an unknown with a value of $500. Okay, that's pretty sweet. Okay, now that we've updated our instance variables, we updated our default constructor. We should probably update instead of having the 1arg constructor, let's just go for 3 here, folks. We're going to go price. We're going to go make. We'll call it a make, and we'll call it string a model. Okay, so now we'll store in the instance variable of price, P. We'll store in make, a make, and we'll store in model, a model. So each one of these parameters is going to get stored in an instance variable. Okay, Now we can go to our tester. We can now uncomment this, and I think we're going to get some errors, which will be fun. You'll notice we have some red here. Cannot resolve the constructor. It says car double. What that means is we've updated. We had our one arg with just the price constructor, but now we changed it. Changed it to have 3 arguments. So we better give it 3 arguments. So this is a Subaru. Keep in mind it's strings, so you need quotes. Now look, it's already starting to set up. This is beautiful. We've got the model, the make, Subaru, and Ascent as the model. All right, so this is looking pretty sweet here. Now let's test it. Test it some more. You have to keep testing it every time you make a change, just to make sure you haven't introduced any weirdness. All right, so we have the unknown. We have the Subaru Ascent. The unknown is super expensive, and your car was decent value. Okay, cool. So now we're updating things even more so. So what have we done so far? We've given ourselves more fields. We've improved our default constructor. We now have a 3-argument constructor. Now we have to do more getters and setters. Okay. Set make. If we're going to set the make, we need a string new make. So in place of make, we're going to store in new make. And we also are going to have to get the make. All we do is we'll return that instance variable, make. Okay? Now, what's really, really cool is I'm on a Mac, so I can just do command, which is like that cool squarish curly thing. I can go command N, and I can say that I want some getters and setters. I have not done one for model yet, so I'll do it for model. And boom. Now, this brings me to another layer of detail that I wanted to hit up. If the parameter, if its name is the same name as the instance variable, you can't just say model equals model. That's shadowing the variable. That's not what you mean to do. Instead, you're going to use this dot. Okay? So what that means is you're going to store in this object. So whichever object is you're calling set model on, you're going to store in its instance variable model the model that you're giving it. So this helps you differentiate between the object's model and the new model that you're storing in it. So you can use this. You can use this notation. Okay, this dot. So instead of price P, you can just call it price, and then you can store that new price in this object's price. I do this dot price. Okay, so that's kind of neat. You could do a bunch of this dots here instead of P if you said price. So you can change some of them, you can change all of them. I just want you to be aware of this. And then we can use this dot. So that's another little interesting wrinkle. All right, so we keep modifying and shaping this car class and testing it as we go. So now we still have our comment on price method. We formatted things nicely. Let's just add one more method just to spice this up a little bit. So let's simulate. We could either simulate inflation or depreciation. Things get more expensive over time. We could do inflation or depreciation. We could have our cars like lose value. So let's let's actually depreciate things. Let's have our car lose some value. All right. So there's a bunch of different ways to do this, but let's just roll with it. I have no idea what's going to happen right now, but I think it's going to be fun. We're just going to call this method called depreciate. Now, we don't need to put anything into this. What we're going to do is, oh, you know what we could do? Let's do this. Let's say how many years we want the car's value, for how many years we want the car's value to decrease by, so, if we wanted to say, well, how much is my car going to be worth in 10 years? Well, we'll give it a number of years, and then we'll have the car lose value, aka depreciate. So let's build our way up to this just for fun. Let's just pretend we're depreciating for 1 year. So I'm just going to shoot from the hip here and think of this as like, let's say a car maintains 80% of its value per year. What that means is that price is going to be what price used to be multiplied by 80%. Okay? So I'm thinking in 1 year, if your car was worth $10,000, 80% of that in the next year, after 1 year has gone by, it's going to be, instead of 10K, it's going to be worth $8,000. Okay, so if you want, you can be fancy and even say this. That's the exact same thing you're saying. Take the price and just multiply it by 80%. So decrease the price, if you will, by 20%. We'll estimate that cars depreciate by 20% per year. So they lose 20% of their value per year. That means that they keep 80% of their value per year. Now you might also say, well, hey, what if the car is, appreciating? Maybe if it's like a classic car or something, well, then it's going to go up in value. But we're just simulating a run-of-the-mill car. Okay? Now what you could do is, let's test this. It's always good to test stuff. Now, let's have my car depreciate. And then, just so I know where we are here, let me just print out a couple of new lines just so I have some space. This brutal, weird indentation thing going on here. And then I'm going to print out my car, and then I'm going to have it depreciate. And then in order to test things, because seeing is believing, I'm going to print out my car again. This weird tabbing thing is driving me bananas. Okay, so let's test our tester now. Oh, okay, and that kind of checks out. My car was worth a lot. Again, maybe we'll make the math a little bit easier, but that does look reasonable. My car is $10,000. We'll just run it one more time, but I think that's probably just fine. It does, estimationally, it looks good. If my car was worth 10K, and it's the unknown make, unknown model, and now, after depreciation, it's only worth $8,000. So that's like a year went by, essentially, because we're saying per year. Now we could also just spice this up a little bit and say, let's say we have n years. We'd call it num years. Well, let's just make this be a precondition. We're just going to assume that it's a positive amount of years. So if we wanted to depreciate, let's say we wanted to test it like 5 years later, it's going to have to lose 80%. I'm sorry, it's going to have to lose 20% 5 times. It's going to maintain its value 80% 5 times. So we're going to do this thing. We're going to end up doing this 5 times. So now what we're going to do in our for loop here, if num years was 5, we're going to start out at 1. We're going to go up to and including the number of years, which is 5. So that'd be 1, 2, 3, 4, and 5. And we're just going to take 80% of our price, and then take 80% of our price, and take 80% of our price, and take 80% of our price. And so we can even print this out a little nicer too. We could be like, in year I, or we'll say after. So after 1 year. After blank years prices now and we'll fix this up in a moment, but we're going to put this underneath our oh boy, power zoom there. We're going to move this underneath our little depreciation code here. So we'll depreciate the code. I will depreciate the code. We'll go underneath the code, and now we'll print out the new price. So I'll just have this be a price. I'll just have this be one line. And actually, shouldn't we just print out? Should we just, we'll just print out the price. It's kind of nice to have this be very clear. Now, keep in mind, we'll need our parentheses here. Let's keep it this way. Okay. Now, let's give this a shot, shall we? Let's go to our tester. Now, depreciate. Oh, it's yelling at me. IntelliJ is very, very helpful. Expected 1 argument, and it expects 1 value to be plugged in. So let's have this depreciate 8 years. Oh, this car is going to go down in value here. It started out at 10K. It's going to be a clunker junker. Let's see how it looks. Ooh, boy. So we got to fix our spacing here. But so the car was $10,000, 8,000, yada, yada, yada. It keeps depreciating. Now, it's wild. And then it's done, and you'll see afterwards. It is, in fact, done. So we just needed a space after blank years. The price is now. Boom. Test it one more time. Again, you always want to make sure that everything you're doing is perfectly clear, perfectly nice. All right, and you know how we had our decimal formatter object for the toString. Let's see if we can take advantage of that in here. Wow, again, I really like this. Let's just see what happens, and then we'll explain what on earth is going on right there. Let's give it a whirl. Hey, nice. It's using the toString now. All right, so let's unpack that. When an object when you dot some object in main and you call the depreciate function on it, what we can do is we can call within this method the objects, this object, the object that you're dotting and using, we can call the print screen on it. So this is truly the object that we are calling this method on. So my car, I got my car, I call depreciate on it. So the this right here is my car. And so then it's print lining my car because that's the object, this object, the object that we use to, that we called the depreciate method on. So it's actually really kind of neat. So now we're starting to put function methods inside of methods and really make this look kind of sweet. Now we have that nice formatting. My car is junky. All right, well, thank you so much for watching. I hope that this was super helpful, and I think I'll even make another video where I go harder in the paint with this car analogy. Thank you so much for watching. Tell me what you thought of this in the video. Tell me in the comments. Feel free to like and or subscribe. Let me know if there's a video that you want to see, and thank you so much. Have a beautiful day.